So hello everyone, and welcome to this plenary 23 session for the IADOPT working group. IADOPT is about interoperability of description of observable property terminologies. My name is Gwen Monkwafe, and I'm one of the co-chairs of the working group. I will be sharing this session today, assisted by Sirko and Barbara. Sirko Schindler, who is a member of the IADOPT core group, and Barbara, who is online, also a co-chair of the group. And for those of you online, please remember to name yourself on the little window so that we can know, other people can know who you are. Remember to mute your microphone when not presenting, and also turn off your camera if the signal becomes a bit erratic. Also, remember that the session is recorded, and you can turn off your camera if you don't want to appear, and use the raise hand to ask questions. So there is a QR code here that gives access to the session notes, and there's also a link on the front page there on the IADOPT working group pages. So, oh yeah. I forgot it was me. So the agenda today. Where is it? It's not working. Okay. The agenda today, we first start with an introduction to the IADOPT working group and the work we've done, as well as the variable modeling challenge that we ran recently. Barbara will do that in 15 minutes. Then Maria Stoica, who is also a co-chair, will take 5 minutes to present the variables modeled during the challenge, which is going to be a challenge itself. And then myself will give an overview of some of the key outcomes from the challenge, but it's really the beginning of what we need to analyze of what comes out of the challenge. And Andrea Tarallo will take 5 minutes to talk about what he did with ChatGPT to provide IADOPT variable descriptions, very interesting work. Sirko will also present a very interesting work about technical development is done related to the IADOPT framework. And we will have 40 minutes left for discussion. And I hope that this time we'll all be maybe more people in the room as well, and some lively discussion. So I'm passing on now to Barbara.
You can stop sharing and I can share.
Stop sharing. And
I hope you can see it. The slides?
Yes, we can see it. Perfect. Yeah, perfect. Go ahead.
So I was asked also to introduce again the IADOPT working group, which is actually at the moment at a status maintaining the deliverables, because we started already in 2019, unofficially already a year before. So, but the active time was from 2019 to 2021, where we got our recommendations endorsed by RDA. And Gwen already introduced some of the chairs. We have also Anu Surya De Barayo, who now is again back in Australia, and Alison Pament, who is part of the core team. But there are many others that helped developing all the deliverables and output of IADOPT. So we are really an old group, but we got the chance to present, to have again a session, because we are still very active. That's what I want to say here. So the idea is, with the IADOPT working group activities, to address the I in the FAIR principles, the interoperability aspects, enabling interoperability between existing terminologies, but first of all between terminologies that provide variable descriptions. And we want to promote the use of FAIR terminologies, FAIR semantics, but also help to annotate research data to make the data itself fair. And so what IADOPT provides is a systematic approach to describe variables, enabling mappings to a common representation, adding rich human, but then at the end also machine readable descriptions using this framework, which is actually based on ontology. And it requires to specify the role a concept has in a description of a variable, but in essence, the existing terms can be reused, but enriched with this fair semantics. And the recommendations in brief are just we need both human and machine readable descriptions. We need to have them explicit and sufficient that others can really understand what our data is about, our observational data is about. We need semantic artifacts for these descriptions, and we follow the ontology of the IADOP when doing so. And if you have to create a new variable description, you should do this aligned with the ontology, and if you can, reuse already aligned terminology with IADOPT. And so the idea here, what is a variable? For us, a variable is a contextualized property. So it's something that we observe. So a property like height or whatever, a temperature, needs some context to be understood. And the IADOP variable is therefore a property with context. So an IADOP variable consists at least of a property, but also of other components. And we call them description components. And what these are defined actually in the IADOPT ontology. And I show here just these classes, but we have done an extension, which is a bit outside of the focus of today's session. But there we have variable sets included also for addressing essential variables like biodiversity essential variables. But here, just these 4 classes, variable, entity, property, and constraint. And I explain this by an example, how these are connected, what we need here. The important thing is we have the variable that is a compound term, or a semantic concept that includes everything what is needed for the description, but it has different components, and these components have different roles, right? It has a property, it has object of interest, a matrix, a context object, and these entities can all be constrained. Let's see this with one example, a simple one, concentration of dissolved lead in river water. So the concentration plays here the role of the property. The dissolved lead needs to be really decomposed into 2 parts. Lead is the object of interest, but it is constrained with the term dissolved. And this lead is found in water, which is the matrix, the material that embeds where the chemical element is embedded or included. So the water is the matrix, and the water is part of the river, and that's the context object. That's the idea. It is possible to decompose a description in different atomic parts. And these can be described with semantic concepts from fair terminology. And what we wanted to do is to really test the IADOPT ontology and framework with a challenge that we started over the summer, so announced over the summer. And we had 2 challenges in September, in October. And we invited researchers from all different domains. So, or it was just an open call and people could participate. So in total, 24 people participated. They could participate alone as a person or as a team. So we had 60 groups and they came from different domains, but I must say all of them were also data scientists. So we had also sent out a questionnaire so that people can say which domains they cover, but all had some data scientist aspect included. So what was the purpose? The purpose of this challenge was to reveal similarities and differences in the way different people use the IADOP framework to describe the same set of variables. So we had 30 variables in total, and they could choose as many as they want out of them, but at least 10 to be counted. And the outcomes of this challenge, of both challenges, were actually to find out what we need to improve the framework and the guidelines, and to provide insights to develop a semi-automated IADOP variable annotation service, because the challenge, everybody who contributed to the challenge have really found out, well, it's possible, but it takes a lot of time to do it manually. So this is not the future. What we need is a service, right? And with this challenge, where we could gather more than 340 modeled variables, we can really start building this service based on LLMs or NLP techniques. We had two challenges. The difference is, at the beginning, we had 30 variables. In the second challenge, we had only 10. Those with the highest variance from the first challenge. In the second challenge, only 5 counted with the highest quality. So the quality means that they could address each of the atomic parts and align them with, assign them semantic artifact concepts. The winner principles at the beginning was, at the first one was the highest scores, and the second was that everybody got a share from the prize spot, and the time was also different. The first challenge was 2 weeks, the second 5 only, but the second challenge in October was, we included there do's and don'ts, so tips how to model based on the insight we had from the first one. So people were more informed afterwards. But the overall analysis that I can tell after helping to really analyze the whole thing is that the people, the more they did, so if they made more than 10, were much better than those that started just with a few models. Yeah. So although in the second challenge there were the errors that we found in the first were not encountered. This is just a very brief overview of the answers we got from the questionnaire. Why is IADOP useful? It helps to verify data because you can annotate the columns of observational data with IADOP. You can also verify metadata when you want to address what is done in your research, like keywords, but for keywords you can use IADOP instead. So to make it more precise, it helps to manage semantic artifacts, to manage data repositories, to harmonize digital objects, the terminology of digital objects, make data reusable because people better understand what the data is about, and to integrate data. So this was what the participant said to the question. Why it's useful, the challenges are still there. So it's not that we solved everything. And you see here that the most difficult parts are defining the right terminology for describing all the atoms, understanding the variable itself, because you need to know a lot about the domain of these variables, and to do the correct modeling. For the correct modeling, I think we can do a lot with improving the guidelines. Because sometimes there was still some doubts how to use it. Yeah. Also, an issue some terminologies don't resolve, and that has to do with the persistence of identifiers. As Ben already knows, we discussed in the last weeks that this is very often an issue. Then we produce these do's and don'ts. So this is, I think, something that's really helpful. So I am not going really through that, but this is a possible improvement of the guidelines that we found out. here you see the reviewer team. So it's the core team, the 6 people that are involved there, plus 3 external reviewers. There's Markus Stockel from TIP, Germany, John Graybill, you probably all know, and Rob Atkinson from Australia, but he is working for Open Geospatial Consortium. And I'm very happy that we had these external reviewers. They did with us all the review of all the models that we got in. So as I said, we have many of them. It was quite some work, but it worked out well. The challenge material were prepared in the summer. We had the introduction video, and a step-by-step guideline video and instructions how to participate. Also the scoring rules, the list of variables and the questionnaire. And the people could submit their variables either as human readable, as an Excel or text, or as machine readable output in nano publications or turtles. And the evaluation sheet included all the variables, and you can see this all transparent. You can see that they're all there from all the participants. We normalized them and presented them as Excel. You see there also the scoring reference and also all of the criteria, which was very detailed to be able to compare all this. You see also the modeled variables by the core teams and the agreed models, because we had to agree on the models to be able to score them. And we have published all these, or at least the agreed models and many of the variables as provided by the participants in the IADOP variable examples repositories, and we will continue publishing them. And we have a GitHub issues for discussing variables models. So you can continue to discuss on them. Last slide. These are our winners. First prize, and I have to see if Anne is actually here. Is Anne here? I'm not sure. I don't see her. Anne Fouillot is the winner, together with Jean Jaquinta. And they got €400 plus the virtual attendance fees. And I'm not sure, I have to check if she is here or not. Yeah, I don't see her.
Yeah, Barbara, can you hear me?
Yes, I'm finished. That's the last slide. Yeah.
Yeah. Okay. Yeah. Yeah. Please. Yeah. Rapidly, but we've.
Yeah. I'm finished. No. So second prize goes to Andrea, and Andrea will talk. Andrea and his team. He will talk and present also. And the third prize is Jörg Clausen, Morgan Silverman, and Gao Chen. And Morgan is here. So congratulations again. Very happy that you participated. But we had in the second challenge many more that were also they also got a prize.
Okay,
Thank you very much.
Thank you very much, Barbara. We've got a little technical problem here in that we can't see the slides. The projector decided to just back up.
Oh, no.
So, I mean, I'm glad it's still available online and it's still recording and all that. So, but the people in the room can't see the slides at the moment. You can enter Zoom if there is connection. Yeah. So, hold on. I'm just going to switch off the microphone. Okay, right.
Looks like the power is issue, and because of that, it's rebooting and takes a lot of time.
Okay, I'm going to switch off the microphone just 2 minutes. So please be patient online. We're coming back in 2 minutes with some solution and some options. Okay, it looks like we are back on. So if we could pass now to Maria to present the next.
Yes, I will present for you, Maria. Okay.
Yeah, that's
or share the slides and you present. Sorry.
That sounds good.
Okay, the floor is yours, Maria. Thanks.
So I'm going to just talk a little bit more in detail about the variables that were included in the challenge and how we selected them. So the first step before the challenge was set up was to source variable options from the core team members and also from community members. This was a very long list, and then we also, for the variables that were obtained, we obtained definitions from the source. So we did not define those variables ourselves. And then we had the core team members looking at the variables and trying to determine the difficulty level. No, I'm sorry. So the first step was to narrow it down to, am I saying this right? No, okay, yeah. So first we determined the difficulty levels of the variables, and that was just simple or advanced. And then later the scheme was improved because this was just from an initial analysis of the variables, so not a deep look at them. And then we also determined the domains of each variable. And then in order to select the 30 variables for the challenge, we chose a mixture of simple and advanced difficulty variables, and also a mixture of domains. And from these 30 variables, participants were encouraged to choose the variables that they were most interested in modeling, and only the top 10 scoring variable models were counted towards the final score. And of these 30 variables for the second challenge that Barbara mentioned, 10 were selected for the second challenge, and these were the variables with the highest variability in the modeling during the first challenge. And for the second challenge, participants were asked to select 5 to model. Next slide. Here you can see the distribution of the domains for the initial set of 30 variables. So you can see that there's a wide range of domains that we covered, mostly in atmospheric and earth sciences, but also some in health and social sciences, and even space. And here is just a snapshot of a few of the variables. I believe we've shared a link to the full list of variables, but here you can see that we provided a variable name and then an accompanying description. So some variables had a relatively short and straightforward description, whereas other variables had a more complex and involved description with a variety of parameters. And you can also see that the unit or value that was provided for each variable is important, because that gives you some insight into what the variable is modeling. And also you see the difficulty levels in the domains there. And this was the last set, the final set of 10 variables that had the greatest variability in modeling. And as you can see here, these are a little bit tricky, because either they don't, there's a lot of variability in how you could model these variables. So yeah, thank you. And this is just a snapshot of, Barbara touched on this earlier as well, but essentially the scoring rubric for each of the variables was based on these 5 components, how the components were modeled, whether the components were accurately linked to outside sources, providing concise and clear variable description, the machine readability of the output, and whether or not constraints were identified. And these items were scored. Each of these had different scoring elements within those categories. And the scoring was on a scale of -1 to 1. And then based on the difficulty of each variable, it was weighted by a factor of somewhere between 1 and 2.
Thank you. Gwen, it's up to you now.
Thank you, Maria. Thanks a lot. So can you share these slides again, please? Or go for, oh yeah, sorry, I can do it. Yeah, I hadn't thought about that. So I'm going to focus, now that you've got a good overview and background information about the challenge, I'm going to focus on some of the key outcomes, but we still have got a lot of analysis to be done on the results that came out of this challenge. So I'm going to focus on maybe some of the aspects where we could find easy consensus, and it could be really helpful to start building a common base, a common understanding, common consensus about how to model certain type of variables using IADOPT. So the first example is variables that relates to cover or coverage of something by something else. So we had 3 of those variables, not intentionally. It just happened that 3 of those were fairly closely related, but for very different domains. So we had the cloud cover, we had foliage projective cover, we had coarse woody debris abundance per hectare. So initially they just sound a bit different. There are different dimensions as well, or different ways of being expressed. So the cloud cover is based on an octa scale. So the sky being divided by 8, and then the number of 8th section covered by cloud. The foliage projective cover was percentage, and the woody debris abundance per hectare were in square meter per hectare. So initially, so how can we find common element there? So really, they're all, when you think about those 3 variables, they're all area fractions. And then of something, in or on something. Content of something that is contained in or on something. And this is when we model that using the IADOPT framework. Obviously, area fraction is a property, and it can be easily found in some vocabularies of list of properties, well-defined property, and the of something is the cloud as an object, and in or on something is the sky. So the cloud in the sky, area fraction of cloud in the sky, and the expression is in octa. And then if we look at the coarse woody debris abundance, which is, I believe, one of the essential I think it's an EBV, but anyway, it is a it's commonly used variable. Again, here, area fractions, very, the same as before. Of something, now the object entity is changed. It is coarse woody debris that is also defined in some list that are relevant to the particular domain being looked at, and the matrix being the ground. So again, a common way of, if we look at the foliage projective cover, then it is the same. Basically, all what changes is the object of interest, which is in this case, the foliage, and the matrix or the entity on which this is, against which this is measured, the ground, is the same as the previous example. So if we use common vocabularies to annotate those terms, then or we use vocabularies that are actually connected to each other, then that's when we can test interoperability between the different data sets. Another example is about concentration and content. So we had three different types of concentration of content. We had mass concentration of isobutylene in chloroform. We had concentration of DDT in a given year at a site impacted by industry. And we had the amount of Docos docosahexaonic acid relative to dry weight in an individual. So I must stress that those are the definition or the description we were given. So we just had to work with that, or all the participants to the challenge had to work with that. But thankfully, we were also given some typical, well, the units in which those variables, those quantities came. And you can see one was in grams per liter, one is nanogram per gram, and one, again, a mass per mass. So really, this follows a model which is quite common in science, which is a mass of something in something. So sometimes called a concentration, sometimes called a content. But this is something we will go into later. So if we look at the concentration of isobutylene, this was actually a mass concentration per unit volume. But mass concentration, so yes, sorry, mass concentration per unit volume. So we found the quantities that related to that mass concentration. Then the entity is a chemical entity, which again can be well defined in chemical entity vocabularies or authoritative list of terminology like KB. And then the chloroform being the matrix in which that chemical entity was measured. So if we look at the concentration of DDT at a site, that was actually expressed in as a mass fraction. So previously, this is a mass concentration, where now the property is different because it's relative to the weight of soil, and it is a mass fraction. And that, again, can be well checked against authoritative list of properties. The entity is just a chemical entity, the DDT, which again is well defined. The soil can be obtained from control vocabularies. And in this case, it is possible also, if required, to add a constraint to say that the soil was actually, well, in this case, it is required to add a constraint to say that the soil was impacted by industry. But it comes on the top of what is, in fact, a core variable, which is the mass fraction of DDT in soil, but in that case, impacted by industry. So there are some pitfalls to be avoided, and this is really about looking for exactly for the definition of what we're talking about. And mass fraction is different from mass concentration. By IUPAC defined concentration as per unit, you know, in relation to a volume of a matrix or a mixture, never a weight of a matrix or a mixture. And this is, so it should be mass concentration. Well, if it is per unit of mass of something, then it's a mass fraction. Then again, the other example about concentration and content, we had the mass concentration of a particular substance per unit dry weight of something, of tissues or in an individual. And again, you can have same property, entity, object of interest and matrix as before, but here again, we need a constraint to specify this is dry weight. And then it is possible to add a context object in this case, but and in this case, we added individual, but it could be, it's something that can be refined. We can think about, you know, exactly the different ways of modeling this this particular variable. So this is now looking at the concept, at the URIs that were used, so the different control vocabularies that people use to reference their terms during the decomposition, during the challenge. For properties, we use 37 resources, or people use 37 resources. It's not we, you know, but including the core team who was also doing the modeling. And so there was 14 individuals altogether who used 37 resources for 30 variables. So quite a widespread, but as you see, there's a long tail of resources that were only used once. But really, we can pick from that some winners, really, in terms of resources that cover quite a lot of properties. Also, many resources were maybe not appropriate to what we were trying to do, but even if they had the particular term, it was not an appropriate resource. But it is, as Barbara said, it is very time consuming to do that. And there's many pitfalls to be avoided. So with regards to the spread of semantic resources for the object of interest, there was slightly more resources used again, 57 resources in this case. And this is because basically it was going to different domains that were very specialized. There is clearly a need for more guidance about how to select the resources. And this is something, as a group that we want to tackle as well going forward. And criteria based on fair mapping compliancy will be important. Hence, we are we are going to be involved in the work done by the fair mapping working groups that is being set up under the RDA umbrella. And again, artificial intelligence and large language modeling and will be of assistance. So we need to consolidate best practices and guidelines. As Barbara said, we have already started putting some together, but we need some selection criteria for the repositories that are going to, or the vocabularies that are going to be used for this decomposition, to choose the appropriate one for the variable components. We need to be aware of ambiguous terms, things like density, like concentration, like height. We saw a lot of variability in interpretation of those terms, and some of them were actually not appropriate for the variable that we are looking at. So really, if we are human beings, we can look at definition, and in that case, it's needed. So this is where if we use AI, then we will need that layer of human quality check inevitably. Context is important. Again, that can be derived through AI, but we also need human to actually make sure that the context of those vocabularies is appropriate for what we are trying to do. And then choose reliable resources that are based on FAIR principle for semantic resources, but also for mappings. And so this is just my last slide. It's just to show an example of misinterpretation. We had electron density in the solar wind there, which should be modeled as number density of electron in the solar wind. One of the answers was actually coming up with electron density in the solar wind, which could be appropriate, but the fact that electron density was coming from a terminology that was related to biological imaging methods, ontologies, is really clearly not appropriate for the kind of variable we're trying to measure. So that is just an example of things that can be done if we don't, if we're not careful. And now I'm going to pass the floor to Andrea Tarallo. Andrea is going to share his slides.
And discussions will be able, we will have this afterwards.
Yeah, we'll have all the questions at the end, yeah.
Okay, I hope you can see my screen.
Absolutely.
Yeah, thank you. Thank you for
Andrea, sorry,
yeah.
It's not in full screen mode.
Okay. Let's see.
No, it's still the same.
Why?
Press F11.
Okay, cool. Thank you very much.
Thank you.
Okay, so thank you for having invited us to show our work. I'm presenting this also on behalf of my teammates. As Barbara says, we participated in the IDOP challenge in the traditional way, let's say. But we soon realized that this task could be also done using ChatGPT. And here are a few slides to present what we did. I don't think I have to say much on ChatGPT. It is an AI-powered chat that is able to understand a human-like text, and probably this is the reason why it is very popular. And the graph is just to say that this is a huge thing in any field right now. We cannot ignore it. And indeed, there are also already several discussions happening on the use of AI for data management. We use the last available model, which is ChatGPT 4.0. I reported here some bits of the conversation. And as you can see, we decided to be kind in our interaction because there are some indication that says that if you're nice when talking to ChatGPT, you get somewhat better results. Nevertheless, instead of explaining the adopt model, we gave directly the ontology in RDF. But apparently, this approach was not successful. Indeed, ChatGPT failed to understand the mapping logic. So we decided to train ChatGPT, giving it 10 random variables that we did with our mapping. Of course, the mapping we provided was done by us, so we assumed that it was correct. And another thing is that we did not provide it the definition that, as when was said, can be important, an important part to understand better the context of the variable. So at this point, we asked ChatGPT to map all the 30 variables, and including those ones that we already provided. And this is the results that we obtained. Of course, just after just a few seconds of interaction, and this is undoubtedly the advantage of using such tools. Oops, sorry. And here I try to visualize in a simple way the results that we obtained. I scored the variables with a very simple evaluation model. With those three possibilities, I confronted the correct mapping that was provided after the challenge, the agreed models that was provided. And I confronted with the mapping that was made by ChatGPT. And for each of the properties, I assigned 1 point those that have an exact match, and 0.5 if it can be improved, and 0 if the mapping was completely wrong. In the first graph on the left here, I plotted the average for each category with the standard deviations. And you can see the property and the object of interest scores fairly good, while the metrics, the context, and the constraints are below the basically 0.3. On the right here, I made these metrics, which shows a bit more detail, the score of the mapping for each of the variable. In this case, they are in order of the difficulty level. Black is the exact match, and the gray one is the those ones that can be improved. White is either wrong or missing. And by high, it seems that there is no effect of the difficulty level. And if here we remove the 10 variables that we use as training, you see that the number of correct mappings of metrics, context, and constraints drops almost completely. We also try to obtain nano-publication as RDA files. The result was not really satisfying. In yellow, you see the differences, but here the most important thing is that the mapping is all wrong. Even if the mapping was done by ChatGPT previously in a correct way, the mapping of the same variable. And here it is interesting to see that ChatGPT reported an URI to describe this, but this is wrong because it points to a URI that is not relevant for this variable. And here is also funny to note that ChatGPT attributed this RDF to me. This is my ORCID and not to itself. So in short, we found that ChatGPT 4o needs some training to succeed in this task. We obtain good results for the property and object of interest, not so much for the other properties. We don't have very good results for the production. They are indeed below expectation. And we also identify some gaps. Of course, we use the free version of ChatGPT, so we don't know if the paid version can perform better. Also, the training was done on our understanding of the model, which might not be entirely accurate. Also, as I said, we did not include the definition in our interaction. This might impact the results. And also, finally, the IDOP model allows for, let's say, different interpretation. And I think that when it comes to interpretation, this is in general what AI misses in general. So that's all for me. Thank you.
Thank you very much, Andrea. So as we say, we'll have all the questions at the end. So Circo is now going to.
Can I just say something? In the meantime, I have added all the links to all the resources we mentioned in the notes, so people can really find everything there.
Okay, just having to find the slides again. Okay. So part of the technical developments, we were in discussions with the OGC of including the IADOP model into the new version, I think, of OMS, observations, measures, and samples. And one of the requirements for that is that you have a JSON LD mapping and shackle shapes to describe the model so that they can validate whatever data comes in and gets out there. So yeah, we started working on that. And this is what I'm going to show now. So first thing is the shackle shapes. So first of all, why do we do that? Pretty much schema validation. So we've already seen also in the challenge that sometimes people didn't really pay attention to the cardinality requirements that were set out in the model. So part of that would be caught by such shapes here to validate. So how do we do that? Yeah, okay, it's shackle shapes. So this is a W3C standard that allows you, okay, like here you see on the right-hand side to describe certain schema rules. So what we have here in the rule is pretty much just stating that we always need exactly one property. Yeah, so it says min count is 1, max count is 1, which means it needs to be exactly 1. And it should point, this is the node kind line on the bottom, should point to another URI. So something that's defined in some repository. Yeah, if you want to have a look at, this is still under construction, but here you have the URL where currently all those schema files are residing. And we are looking what we can actually validate. So most of the stuff is cardinalities, but we are kind of trying to look what else can be validated. So, yeah, okay. If you want to try it out for your models, maybe for the ones that participated in the challenge, there is by the European Commission, they funded the creation of a shackle validator, which has this website. You can see on the right-hand side where you can just plug in the shape definitions, your specific model description, for example, then press verify or validate. Let's validate. And then it will show if you adhere to all the rules, which in this case here passed successfully. They also provide a Java-based command line client. So if you want to do that in, say, a CI/CD environment in an automated repository or somewhere else. Then the other way, or the other thing that was requested was a JSON LD encoding. The Y here is more like a compact representation. So if you put an IADOP variable in Turtle or in RDF in general, it gets rather extensive. And with a JSON LD, we have a more compact representation that can be shared. The other thing is that for JSON, many APIs speak JSON natively. And so you can here really use the best of both worlds. You can connect to existing APIs, use the JSON part, but also having your semantically enabled applications that use the LD part in that. And of course, if we have a JSON, we can also validate that here. Yeah, that's just a standard. Again, same URL as before. And here, this is just an example, not so much from the schema definition, but how such a JSON LD document can look like in the end. So as you can see here, it's a pretty simple example. It just shows one property, one object of interest. This is our default example, or the reduced version of our default example we are always using. So it's way more compact than having this entire RDF overhead surrounding that. Yeah, so I don't think I want to explain it now in detail, but yeah, should be easy enough. Maybe one thing of note, as you can see here, I was even more lazy than usual. I introduced aliases, so object of interest can be aliased by OOI. So just to shorten it even more, and there's 1 or 2 more abbreviations in there, at the moment at least. Okay, yeah, so as I already said before, between JSON LD and the turtle representation, there is converter, so you can easily convert back and forth between those. So it should, the JSON LD should be an easy enough drop-in replacement for most semantic applications. This is a table of what I can validate. So I'm not an expert in either JSON schema nor SHACL, but those are the things that I could come up with. And what you can see if you look exactly, there's 2 differences in here. So stuff that I can validate via SHACL, but cannot validate via JSON schema and vice versa. So in particular, currently I have no clue how I could validate in SHACL that the variable itself has an identifier. If somebody has an idea, please drop me a note, then I can include that. And on the other hand, in JSON schema, I'm unable to validate that a constraint always points back to one of the entities used in the variable. Again, if somebody has an idea, please let me know. In SHACL, I can do that via a Sparkle query that can be included. I have no clue how to do that in JSON schema. And then maybe for the last thing that I wanted to show, something that you have already seen on the other slides, all the visualizations of variables can now be created automatically. So you just drop in, technically currently you have to drop in the JSON LD version of that, point it to a specific URL and it will give you back this visualization, which we already used in the example repository, because we got too lazy to always draw up all those images for all the variables that were discussed. So at some point this needed, this needed automation. So there's still a bunch of bugs in there. If you find something major, please drop me a note as well. The link is in the visualizations always on the lower right-hand side, so that you can easily open up an issue there. And what the intention is here, how to use it currently. It's hosted at GitHub, IO in this case, just a static site. And if you pass it as a parameter, the JSON LD version of your variable, it will return to you the image. And what I want to do later is really having an interface like shown here. This is a very early version of that where you can drop in also the turtle file and whatever you have to generate visualizations, for example, for papers or presentations or whatnot. And I think that's already what I wanted to talk about. And we are finished now with the presentations. And I hand back to Gwen for the discussions then.
Thank you very much, Jaco. So we're 5 minutes late, but we still got a good 35 minutes for discussion. So first, any question from the people online or from the people in the room about what you've just heard, seen? Yes.
We don't hear, so.
Sorry, I forgot. Microphone.
So for some of the, is this working?
Yes.
Oh,
Yes,
can't tell.
it's working.
Yeah. So for some of the property terms and some of the relationships you were trying to link together, did you look into see what terms existed in like relation ontology and unit ontology and add to those collections versus just creating new terms so that you could use or expand those large collections as a whole, if like the whole community could use additional properties or additional units with better descriptors? Because I will agree, a lot of terminologies kind of don't really have great descriptions sometimes, and they just need to be updated. So is that considered at all?
Can I answer that?
So basically for the challenge, we didn't create any new resources. We actually reused, and this is the, one of the main goal of iAdopt is to reuse what exists and to improve and extend what exists before we create anything new. So yes, definitely and all the links that were used in the challenge were actually links that already existed.
Yeah, so I just
Barbara, do you want to add something?
Yeah, I just wanted to say there was nobody creating a new. So the only things that you would create new are the variables themselves. So, but not the atomic parts. They exist. This terminology exists. You can reuse them. Could be that the constraints don't exist, but everything else exists. Can you hear me?
Yeah, we can hear you well. So basically, we will extend only if needed. And it's not going to be we, it's going to be whoever wants to model a particular variable within the domain they're working. There will be a need at some stage to extend vocabularies, no doubt. But this will be done, in their particular domain. Yeah. Thank you. Alexandra, hello.
Hello. So my question is, let me just, is to Andrea. So because I hope I heard well, Andrea said that during giving all these challenges to ChatGPT chose some terms from vocabularies that were not the good ones, or they're not the right ones. Would it help if you had a list of vocabularies that you could only choose from to then ask ChatGPT to refine your results only using those vocabularies?
Yeah, I think thank you for the question. I think first of all that is strange that ChatGPT put a real URI there, because technically the version I was using is not connected to the web. So my best guess is that it just saw a URI on the RDF that I provided and invented a URI on the basis of that, and probably guess one URI by chance, just changing the last number, because it was the KME vocabulary, so it's a bunch of number. The URI is always the same. It only changed the number at the end. So that be possible. So this is why I think it would be nice to see the version that is actually connected to the web to see how it responds. And of course, now narrowing down the number of resources that it can browse can be probably, the best way to focus the search on some of these resources.
Yeah, and maybe an outcome of this group would also be a suggestion per domain, for example, matrix, property, object of interest, to have suggestions of very well used vocabularies for those domains. And with that, I'm gonna advertise the V6 session, which is doing exactly that. So there is gonna be in the V6 session, the vocabulary semantic services group session at 4 p.m. UTC. Your time is, so it's the next session after that. It would be ontology and term selection. So how to actually select the right terms and ontologies to do the job that you want to do. And I think it's very relevant to actually be able to do this this one modeling of the IADOPT.
Yes, it definitely is going to be very useful. Thanks, Alexandra. And it's at 10 o'clock. Yeah, next session.
Thank you.
Barbara, do you have a question? Or maybe you want to...
No, just an addition to what you said, Alexandra asked. So we are planning to work really on a service development in 2 projects where we will exactly do this. So we will allow to really restrain or refine the choice of vocabularies for a specific domain. So you can say, please take all the concepts from different vocabularies or from a repository of vocabularies. And we also want to allow to humans, right, the people that address or come in with their descriptions, human descriptions,
they then can correct the output of the service. So it should be an interactive tool that we are going to develop here. And we hope by next year at this time, we can already show something.
And thanks, Barbara. Are there any other questions? Yes.
Thanks. You mentioned the mappings in the same theme, so it's finding concept URIs, and there was a mapping compliancy. Could you elaborate a little bit what the idea behind that? What would it be?
It would be mapping compliancy with whatever recommendation the fair mapping working group would come up with. So basically, creating those mapping is time consuming, or it's something that we're going to use those mapping to build on those mappings. So we need for them to be there, and we need to trust them, and we need to make sure that they are there for the long term. So this is why we want to bring iAdopt as a use case for the fair mapping working group, to enable to have some degree of confidence that the mapping we're going to use, so the mappings that will be hosted in a terminology repository or in another repository, maybe specific to mappings, can be relied upon, are there for the long term. So that's all I meant to.
And you are referring to mappings between the concepts, for example, that are used to model the iAdopt variables, right? I see nodding.
Yes, that's right. So it's basically the mappings between the UI for the variable, for the entire concept, iAdopt variable, and the components.
I see. And this actually brings me to another question that I had. So this is kind of like a fundamental question that I haven't figured out yet. So when is the right time to create these iAdopt versions of the things that you are working with, and should these variables, iAdopt variables, be reusable? Are they designed to be reusable?
Yes, they should really be reusable. You can use iAdopt without actually having a composite iAdopt variable created. So it is possible to do blank mappings, in an internal system, just to map a concept to a property. So just a term that doesn't have, but to have that link. So in that case, it wouldn't be a mapping, or it would be I don't know what to call it, is it blank mapping, the term? To have, okay, in my spreadsheet, that header as property, this as object of interest, that as, and those components that would become available for machine access. Does that make sense?
I think so. I would like
it's a special use case, probably not the most desirable, but because really we try to create resources that will be reusable. Anybody wants to add anything? Barbara, do you want to add anything to that? Or?
So I think, I'm not sure, but it could be that you mean that we have a central repository of reusable variables. And actually, that will be very hard, because if this is mentioned, because you said, where do we have reusable variables? I think there might be these variables definitions in the different domains. So it will be always distributed. And not a central repository. But it could be that the registry of mappings, so what you are doing, Jonas, could be an entry point for that. But we have to discuss this so that we can share commonly used ones. But I'm not sure if this is useful, and probably could discuss it here.
Okay, can I just add? I think you misunderstood what I was saying. I'm not.
But Jonas, what Jonas was saying.
No, I don't envisage a central repository of variables. It's just that if the variable is given a UI, then it can be reused.
I know, but I was extending it a little bit. Yeah.
Pardon? Yes. Yeah. Because there will be, yeah. Yeah, of course.
You mentioned the mapping between IADOPT variables. So would that be, so let's say that you have two URIs that point to two different IADOPT variables. So is the idea there that you have basically it could be the same thing or a similar thing, just expressed, or the components use different vocabularies, for example, but you can say that these are actually same thing.
Yeah, so I think that's the next step that we want to investigate and go more in detail, is really to evaluate how interoperable are the different IADOPT variables, yeah, that might use different vocabularies, right? So we don't have a definitive answer yet, but that's the focus that we will put on in the next weeks.
And maybe something links, or that kind of links could be also generated based on the information about the vocabularies. So if there are mapping between the vocabularies being used as part of the IADOPT variables, you could have some kind of suggestions that these are similar, or maybe even other kinds of relationships between those IADOPT variables.
Yeah, and I think, sorry, Gwen can say something about the work you are doing to map in the NERC vocabularies from the standard names initiative, CF standard names to other NERC vocabularies. So you are using IADOPT as a bridge, no? As a
That's correct, yeah. So basically, we're mapping two or several complex vocabularies that describe variable in detail. And because they are difficult to map one-to-one, we use IADOPT as a semantic bridge between the two. But I also wanted to say, like a year ago or 6 months ago, we came up with, we've got 4 different use cases for interoperability testing. And some of them involved, you've got 2 URIs for a variable. They use the same vocabularies, and you can, they use the same vocabularies for the decomposition according to IADOPT, and then it's easy to actually see the similarities. Or they can use different vocabularies, but those vocabularies are actually connected with each other. And again, this is something going forward. This is something we are going to reach eventually, is that, you know, the vocabularies that are very useful, very valuable, will actually map to each other, and with reliable mappings. And then we've got the situation of the blank mappings, so very, very local mapping, if you want. And then where all that is apparent is the property is this, the object of interest is that, the matrix is that. And the other use case, I can't remember, but anyway, it gives you an idea. Basically, we've got, you know, 4 use cases to work on that will involve mappings in different ways. Yeah. Anybody? Oh, Alexandra, do you want to add something or ask?
Yeah,
something?
maybe just adding one thing that has already implemented on our side, on the side of Gwen. So we have used the IADOPT framework to be able to go up and down the granularity scale. So we have a very, very detailed vocabulary called P01. So the description of the properties is very, very detailed. And then we have a very coarse vocabulary. And we describe both with the IADOPT. And really, these descriptions are acting as definitions to create Sparkle queries, and then bring, so we say, and create dynamic mappings instead of actually doing the mappings by hand. So one coarse variable may be associated with many detailed variables. And because we specify these mappings, the mappings are, we express both all variables with IADOPT, the mappings are created dynamically. And that's, we have already done that, and it works really nicely.
Yes, that's a good point. Yeah, thanks, Alex. Is there any question about that particular aspect, or no? Okay, thank you. So no more question about the presentations. No? Online either. So we had a wish list for discussion, and really it's things we feel we will need to focus in the next few months. Some of the parameters in the challenge had actually they had statistical parameters. They had like maximum temperature, or maximum daily temperature even. The mean of something, so there is really a need to consider how does IAdopt, how can we use IAdopt when we've got statistical measurements associated with the main variable name.
Should we go for that for now
So
and
we-
try to
yeah.
address this first?
Yes.
Can I
Anybody?
say something about this? Because we have a proposal, right? But we can change it, and it would be nice to have your view on this. Can I share?
Go ahead. Or do you want to share?
Yeah.
Okay.
I hope you see this. This
Yes.
is actually one of the variables we had in the challenge that was called the maximum air temperature at 1.7 meter, right? So what we can do in IAdopt is we cannot deal maximum, we cannot deal any daily or temporal information. We can just say air temperature at 1.7 meters. So we can use the atomic parts for that, for the first part, right? But if we want to add maximum, we need to use modifiers, something in addition. It's not yet included in IAdopt, but you can think about modifier properties or extension properties, like has property, has object of interest. We could use any object property found in another ontology, that we can agree on, to add this to the variable description. So used modifier, for example, I don't know, or we can also use, people want to use units, they want to say that what they have in the table, in the column, right? They already want to use to define which are the units they are using, right? And then you could add used unit or whatever property we are going to use, and then you could add the unit there. If you have also some time resolution information that you want to add, it could also be added like that. But it's always the variable, based on this IAdopt plus additional qualified references. Just as an idea how we can make use of this, because I know, for example, the long-term ecosystem research networks requests this, and we could extend this in our description. I think I have.
Can I clarify, Barbara? Would those be additional properties in the ontology then?
Yeah, or it's not probably IAdopt ontology, but recommendations how we can extend it. I don't think it's part of IAdopt, but we can give some hints how you can use an IAdopt variable plus additional modifiers, plus additional properties. I don't know. It's up to us to discuss.
Yes. So any reaction to that? Any thoughts? Petra?
Just a personal opinion, I would very much welcome to have the modifier for minimum maximum, because at least what I get on a daily basis, I see all the time scientists using minimum depth, maximum depth, and that was something that I was really missing in that description. Also the units, I think people really think in units, but to make sure that a property can have that modifier that would specify it more accurately, I think for accurate scientific mind that would be useful.
Okay. Thank you, Petra. Andrea?
Yeah, one question. Why you can't have more than one constraint on the object of interest? Is that a limitation of the model, or why? Because I see those addition that can be also constrained or not.
Sorry, can you repeat? I didn't get it.
If why you cannot use the multiple constraints on the object of interest?
You can have multiple constraints on the object of interest.
Because from the logical point of view, the addition that you showed, this was what I thought when I actually did the challenge.
It's not a constraint, it's additional. So I showed here how I applied it just for an example, right? In microgram per liter, that's something that we normally don't add in a variable because a variable can actually be expressed in different units, right? But I just wanted to show how it would work. So I added here unit of measurement, but whatever property we are going to recommend, but you would then add it here, right? It's just an additional component, an additional description component, but it's not a constraint. It's not constraint. It's constraint if then it constrains the whole variable, but we cannot constrain the whole variable. We have to add additional information. It's like a qualified reference in addition. And we could do it for the daily, for the maximum, whatever, for the statistical information that we would like to add.
Okay. Any other comments in relation to that? So basically the idea would be to use external, so to give a recommendation for how to deal with this kind of additional information using properties from other ontologies.
Yeah.
Yeah. Okay.
I can also go to the last slide again, so you don't have to switch.
Oh yeah, thanks. Yeah, brilliant. Thanks.
Is it good enough for slideshow?
Yeah, if you could make it bigger because the light is not great. Okay. So the other questions we had is, should we allow the property class to be constrained? And this is an issue we found when we've got quantities that are measured relative to a scale, like you might have pH at different scales, or properties that are measured according to a standard or a datum, something that actually needs to be captured with a variable in order to give a meaning to the number we have in front of us. And also for maybe quantities expressed as something specific like carbon or nitrogen. So
I don't understand this last one. What does
so
that mean?
basically, sometimes you might have biomass as carbon of something, or biomass as nitrogen of something. This was just an example. Whether but basically here what is being constrained is actually the property. But there are cases where like the measurement scale, it's not, we can't add a constraint to the object of interest or to the or to any of the other entities. It's actually a constraint on the measurement itself. So personally, I do think that we need to consider allowing constraint to be applied to the property class.
Yeah, but we need to be, so can I say something about that? Because what we did so far is to make a property more precise. So, you can make a more specific concept of an existing property. That's still possible, right? In semantics, or if you have a cost vocabulary, you can make a more precise or a more specific concept. So a child of an existing term. And if it applies to the whole variable, then it is something that we need to add to the whole measurement, right? So the measurement includes, but probably we have to really discuss this also on GitHub, because we have a GitHub issues there, and find real examples to go and discuss them in detail, because without seeing a real example, it's really hard.
Yeah, and we need to weigh the pros and cons of all approaches. So definitely something to discuss, but something needs to be done. We just need to, decide whether it needs modification of the ontology or recommendation of usage. Any question about that? No? Okay, so the next on the list is what to do with variables when the property relates to two objects of interest and none fit either the matrix or the context object definition. And we had that in the challenge. We were submitted a variable which was the distance between two habitats. But when I thought about it, we can also think about measurements. So okay. Yeah, we can also think about measurements related to prey-predator relationship, for example. There are a few like that you might have difficulty fitting that in the IADOP model.
I just showed here the distance example, and I actually got from Yvette Serral, who works on the essential biodiversity variables, exactly on this one. And to be precise in what she needs to be represented, and she said, well, here the distance to the nearest UNIS habitat patch is from a point or a site, right? So
can you make it bigger, Barbara? Can you make it bigger a bit?
I hope.
Zoom on it.
No, it doesn't work. I cannot do it bigger.
Better.
Yeah, sorry, I don't think it is better.
That's better. Yeah, thanks a lot.
But so that's a very the problem there is you have a site, you stand on a point on a site, and you search for the nearest UNIS habitat of a specific UNIS habitat. Actually, it's not the it has different categories. For example, a forest UNIS category, and you are looking for the nearest forest UNIS habitat patch from this point. So you have two objects, right? Your point and the habitat. How do you represent this in IADOPT? And it cannot be the matrix that you are using here because it's not embedded, it's nearby. So it's not you cannot use, for example, habitat as the embedding or the site as the embedding. You are asking what's the nearest one, right? So it must be something else. So it can be the context object, the site. So what we are looking is the distance
Okay.
of the habitat from the site, but I'm not sure. So I'm not sure how to represent
Okay,
this.
so it's something to maybe work with the people who are using those variables and then see how it could be best modeled.
But in general, we need to know how to describe distance variables. And Circo might want to say something about it.
It's coming.
Yeah, so I think that distance is just one of the easier examples. As Gwen mentioned beforehand, the particular problem here is most other variables always describe one thing or one property of an object. And sometimes we are describing the relationship between two objects, which is not really easily fit in that model. Hence, we need a few, or at least guidelines, maybe a few new ideas on how to model that in any case. So some of those that the constraints we saw here is pretty much clutter, which distracts a little bit from the central point, which is, again, describing a property of the relationship and not so much of two individual objects. I think that's the main difference here.
Yeah. Any idea how to solve it yet, Circo?
Yeah, there's a bunch of ideas, but none are currently in a state that's really worth discussing. I mean, one would be that the object of interest we model really as a pair of objects. So it's not the individual object as, say, here there's one habitat, but we have one entity representing this relationship between two of them, which then is detailed out somewhere else.
Yeah.
But I'm not exactly sure if this additional layer in that helps more or is making things too complicated. So this is why I'm still a little bit unsure if this is really the way to go.
But can we discuss this on GitHub also after the session? So continue to use GitHub issues.
So I get, well, I'm not as familiar with the IADOP framework, but at some point it moves from a ontology relationship to a knowledge graph. So the more you don't want to get to the point where you're creating a knowledge graph out of ontologies, because then it just is super hard, right? So, sometimes maybe simplicity is best if gives more flexibility. Yeah. So.
Okay, thank you. So, I mean, in the room, have you tried to use IADOP to model things, or are you, no, so it's a first, okay. So basically those will be GitHub issues that we need to engage more people, see, have more ideas about how to best approach it. IADOPT can solve quite a lot of simple viable use cases, and definitely this is worth worth pursuing. But obviously there are elements more complex, and as you say, it's on the verge of what we maybe should do with IADOPT. So we need to think of other solutions. But all that will be discussed openly on GitHub, and hopefully we'll have some good contributions.
I would have to say, make an announcement.
Right.
So we are working now together with OGC, the working group or task group on the ontology for observation, measurement, and samples, because they want to include IADOPT, or they intend to include IADOPT as a standard for the OMS, so the OGC as a OGC standard for extending OMS. And before we can do that, we need to have to focus on model real examples like time series data with OMS plus IADOPT. And we are we will have this workshop towards March next year. We will announce it via RDA. And we will make sure that, that all people that are working for observation and data and are modelers are invited. So, but it will be open. And we'll give you more information when we have organized it.
Excellent. So could you clarify, Barbara, with regards to the timelines? So obviously we've got those open GitHub ticket issues that try to deal with gather some ideas about solutions for those issues we found with IADOPT. Yeah. Obviously, this is something that would be nice to have, to have already identified the optimum solution by the time of the workshop.
Yeah, I hope so. So I think that will
so
be perfect as preparation for the workshop.
Exactly. So that would be a nice, milestone or deadline to head towards.
And the second milestone would be to really do the interoperability tests, right, with the Sparkly queries across the modeled variables that we have, and also how we can improve that.
Yeah, I think in the next 3 months.
And the improved guidelines.
Yes, in the next 3 months, well, Alexandra and myself, we're working for a European project where we will have to build those Sparkle query to demonstrate the usefulness of IADOPT. So we should have something to show by then. All right. Okay. Excellent. Good. So I think we have reached the end of our session. Well, yes, we are exactly the end of the session. So thank you everybody for participating. We can stop the recording.